Hey folks, welcome to the Trust in the Process podcast. My name is Travis Fritz, owner and brewer at Old Nation Brewing Company in Williamston. As those of you who have watched or listened to the podcast before, you know that we're generally speaking to brewers. We're generally speaking to sort of marketing and salespeople. These are all fascinating conversations. But today, I am happy to have John Blystone, who is an engineer. He's actually in a lot of the packaging and automation at Great Lakes Brewing Company. And of course, you all know what that is, but in the event that you don't, it is one of the larger national breweries in the United States, based in Cleveland, and a wonderful sort of portfolio of brands that have been around for some time. Including the one that most people are familiar with, sadly, in my opinion, which is their Christmas ale. But, you know, of course, the Eddie Fitz, the Edmund Fitzgerald Porter, the Dusseldorfer style, the Dortmunder style, the Dortmunder Gold, and a number of other brands that have been around since I have even dreamed to dabble in the brewing industry. So a venerated company, a venerated individual, John. I am pleased and thankful to have you on the podcast today. Thank you.
Thank you. Excited to be here, Travis.
All right. So, John, in your journey to where you are now with Great Lakes, I assume that and forgive me if I'm wrong, your goal was not to be plying your trade at a brewery initially. Can you tell me a little bit about where you started in your engineering?
Yeah, so definitely not. I don't think I ever imagined I'd be able to apply my engineering degree to making beer for a living. Started out, oddly enough, when I was a little kid with model trains. So I was into trains. I still kind of am. I'm an electrical engineer by degree and automation engineer by experience. And when I have time, which is very limited these days with a little one, I would go and work on steam locomotives. So like the far other end, no wires, no batteries, nothing. Wow. But as a kid, I would be playing with model trains, and no one else in my family knew anything about electricity. And I was just fascinated by what it would take to run two different trains on the same track or wiring everything up, and just loved all that problem solving. And I've got some engineering, I don't know, what do you want to say, relations in the family. So it's kind of exposed to that, like engineering, you know, building Legos, helping out around the house, little projects here and there. And so it came time to pick a profession, and electrical engineering seemed to be a natural fit. By the time I got out of school, definitely did not imagine making beer for a living. By then I was a beer drinker, but limited craft beer, to be quite honest. I won't embarrass myself with what I was drinking at that time. Certainly anything but craft. Started working in the trades. I graduated from the University of Akron, which is, of course, the rubber capital of the world. So naturally into the rubber industry. Worked at a number of firms doing consulting engineering, some machine building, bounced around to a different company that was doing chemical blending, precision chemical blending, mostly in the foundry industry, but also things like fragrance addition lines for some consumer packaged products, air fresheners, things of that ilk. Great exposure to pumps, process piping, you know, everything that we do in the brewing industry. Went back to the rubber industry, was working for some machine builders, but all of that work had me on the road all the time. And I was getting tired of not being home. And oddly enough, my wife actually found this job for me. So you can imagine I've not heard the end of that in 9 years, but very grateful. She was friends with the company on Facebook, and they posted an automation specialist role. And she sent it over to me and said, "Hey, you know, you've been looking to get off the road. This sounds like your kind of expertise." Applied, and here I am almost 9 years later. So that's my path here.
That's fantastic. And believe it or not, as a lowly brewer, I have a lot of friends who are engineers, and it seems like the mechanical and electrical engineers. And it seems like that's kind of the path after college, the normal path to be the guy who's on the road, right? The young guy gets the kind of the shit job, right? You're the one that gets to go out and deal with the customer who doesn't know what he's talking about and solving the unsolvable problem. And it must be actually quite a useful crucible to go through as a young engineer. Do you feel that way?
Oh, absolutely. Akron was great in that they had a co-op program. So by the time you graduate at the end of supposed to be 5 years, took me 6. but you'll have a year of hands-on experience working as a young engineer somewhere. For me, it was Morton Salt down in Rittman, Ohio. So some good FDA exposure as well, right?
No
FDA
joke.
and all those requirements. And so some experience is gained there, but certainly being a road engineer, almost kind of a maintenance technician for all the systems, because you're the lowest man on the food, the totem pole, so to speak, the low man on the food chain.
Right.
Yeah, you're tossed into a lot of situations that you are learning a lot. I think the first 5 years out of school, really said a lot.
I don't purport to be an engineer, right? Obviously, I had several classes that worked around the theory behind the engineering that we use with regard to automation and with regard to systems engineering and electrical engineering in some cases, and some software engineering as well. But that, of course, I'm not so arrogant as to think makes me anything like an engineer, right? It allows me to speak a rudimentary language with engineers, right? That's what it allows me to do. But as a person who deals with the practical applications of engineering quite often, I find myself, and I guess I'm asking for your experience in having these kind of conversations with, brewers like me, maybe, that I find myself quite polarized about the engineering that's happening in the brewing industry, right? Meaning, sometimes I'm fascinated and absolutely astounded by the amount of precision that goes into a machine that operates exactly as I need it to consistently, right? Those are the machines, those are the processes that you fall in love with, right? That you depend upon. They become like your family dog almost, right? Because you know this machine is going to do what you want it to do all the time. And if you break it, you've gotten to understand it well, or if it breaks, or if it degrades or whatever, you've gotten to understand it well enough that you can know what's wrong with it. And if you can't fix it, you can call someone in and you know exactly where they need to go. And these problems are fixed easily. And on the flip side of that, this is what's polarizing to me. There are a lot of these machines, and this is specific to brewing, but I know this exists in most disciplines. There are these machines where it's like, who designed this, right? This cannot work in the way that I need it to, right? I can't tell you, and these are, not complicated machines that I'm talking about, but, brew house engineering, for example. I can't tell you the amount of brew houses that an idiot like me can go back and say, well, these are the problems with the fundamental engineering of this system. And ultimately, there's not a lot I can do to make it more efficient, given that it is immovable, right? This is a circle within circles. I can't change one without changing the others. This is kind of what we're stuck with. Let's figure out how to make the best of it. But who in God's name designed this, right?
Right.
So I can sit back and armchair quarterback about that all day as a brewer, right? What does it feel like when somebody like me does that armchair quarterbacking and comes to talk to you about it?
Yeah. So, I mean, not to disparage my own kind, but it's evident to me as well, right? I can give you examples because I'm normally the first line of defense, or my team is now, when things go wrong or something's not working to the brewer's expectations. Maybe worth framing kind of what we view ourselves as here at Great Lakes. I mean, we're an internal support organization within this company. We refer to almost everyone around us as our internal customers. We're here to serve them, make sure that they're happy with what they're getting out of the machinery, out of the process, everything. So we're just here to help them. But it's evident to us. I mean, we've had machines where we've had faults that are not displayed on an HMI. So you've got things that aren't working correctly, and you log into the PLC and find out they took the time to write fault logic and generate a fault bit that stopped the machine, but it's not displayed anywhere, and you can't reset it from the HMI. Again, frustration of who taught you how to program.
Right. Now I've got all these corners I have to look around that I wouldn't have had to if you just done it right in the first place, right?
Right.
Let's back up a little bit, because not everyone who we are speaking to is a 20-year veteran of the industry or an engineer, and define some of the terms that we'll be using today, if you don't mind.
No,
PLC, process limit control. Can you give a rudimentary sort of definition of what that is?
I can. So I love my TLAs, 3-letter acronyms, right?
Right.
The PLC I'm referring to is a programmable logic controller. So this is an industrially hardened computer, typically used in larger automated equipment to replace banks and banks of relays that in the old days were used to control equipment. So pretty much everything these days, because of the price point, is going to be controlled by some type of PLC. And you open up your control panel, which you should do in a de-energized state, a bit of a safety nut. You open it up, you're going to see, a bunch of wires going to what looks like a big, long, rectangular cube of just electronic goodies. In there is a computer brain that is interpreting all of those sensor signals, running some logic, and then determining how to control, actuators, pumps, things of that nature to automate a process.
Can you give an example of something people might have in their own home that is a PLC, a furnace?
You could call a furnace a PLC in a way. PLC is a bit more of a generic expandable system that's used in industry.
Sure.
You wouldn't necessarily see a PLC at home, but certainly that kind of logic would apply to a PLC, right? Interpret the set point from your thermostat and then control the fan, the heater, the air conditioning through some automated system. There's going to be timers to turn on fans before you turn on the gas blower and then the gas valve and so on and so forth. So there's going to be some logic in there. Similarly with the PLC, but again, it's an extensible system. I mean, you can add things to it. You can log into it, change the program, typically while the code is running. So I can log into our brew house and change how things work without interrupting their process. Right?
And those systems can be infinitely complicated, but what is, when you look at the design, for example, of a system and how the PLC that you would like to put in or that comes with that system is oriented to the system, what is your goal?
Yeah, so my goal when I'm looking at a system design, and this is kind of down in the weeds in automation engineering, right? But there's that whole, like we were just talking, how do you qualify the programmer, right? Most everything in our lives, it's almost all software these days. That's the most important part. But you can get a good indication by looking at how they've approached the hardware design. And what I mean by that is kind of thinking through the criticality of what is this machine going to need to know and what inputs does it need to properly assess what it's trying to automate. For instance, in our brew house, it was automated very early on. And everything was what I'll call semi-automatic control, meaning it went through a PLC, like all the valve signals went through a PLC to a computer human machine interface, or HMI. And the brewers would click on a valve and it would open. It would turn green on the screen and open, but there was no feedback from the valve. All that green on the screen was saying is that the PLC was thinking that it sent a signal to its output to command a solenoid to tell the valve to move. So there's a whole chain of things there that can go wrong. And the brewers are looking at a screen saying, oh, that valve's green, but is it fully open? If you don't have air pressure, it didn't move, but you didn't know that, right? So one of the things that we started working towards, and we're kind of in a holding pattern currently, which is specific to our current situation. But we had started working on automating vessel-to-vessel transfers in our brew house. It's a way that we're going to try to shave some minutes off of our cycle time up there. And right now it's just not our bottleneck. So it's not the biggest flaming bowling ball that we're juggling, as I like to say. But that's an instance where, looking at how a system is designed from the hardware side gives me a good indication of have the design engineers thought through all the things that system should have, because at the design stage, to add that feedback is relatively inexpensive. For us to go back in and add it later is a whole different story. Right. And so, kind of letting these companies say, well, just give me your standard design, and looking at that drawing and saying, man, just every single valve, every single device, how are they instrumenting that device, and how is that then interpreted in the code? How do they write alarm logic? Like I said, nothing buried in the code. It's all going to be front and center in the user's eyes, right? Things like if you hit an e-stop and it kills power to things, well, then don't give me a bunch of fail to open alarms, because we know why. Someone hit the e-stop, and of course all the valves closed, right? I've seen that happen where someone hits an e-stop and you get 80 alarms. Right. That's not helping anybody.
Right.
Trying to sift through that kind of low level, just how do they approach problem solving and system design is typically my first step for kind of assessing an automation system.
So, as a Philistine who looks at engineering as a complicated type of wizardry, to me, I often think when I'm trying to put myself in the position of an engineer, when I'm trying to figure out, for example, a problem on the fly that absolutely needs to be dealt with in a system I understand in principle, but not in practice, really. Those work out or they don't, or we have to call in. But when I'm kind of going over, how I could have done it better, or what I need to know in order to deal with that problem later, what I need to learn. Often I'll get kind of caught in this philosophical question about engineering, which is there must be a challenge, right? Particularly after you've done it for a set amount of time, right? I would say that older engineers probably have faced this issue and found their own way through it. And so I'm asking you, what is the significance or what is the weight of trying to make a system as elegant as possible? Meaning there's nothing there that you don't need, right? And yet you do have all the things that you do need. Must feel almost impossible as you start in that job, right? I mean, what matters and what doesn't matter? It seems like a simple question, but it must be really difficult to deal with throughout the design of a system, if that makes sense.
It is. Yeah, it is. And I will say, though, interesting, back to that theory that most everything these days is software. And the hidden statement in that is that hardware has gotten inexpensive, right? Okay. Relatively. And so I think the question, certainly in the last part of my career so far, and I'd almost argue from day one, is that designing for agility is really the key. And you'd probably be able to design in a lot more hardware up front than you'd imagine, that the cost differential is not necessarily there. Certainly that eloquent design, right? It's everything it needs and nothing that it doesn't. It's great in theory, but right. What I have found is that more the better, right?
Sure. Okay.
So a great example of this, right? We went through a process shortly after I got here of upgrading all of our variable frequency drives, or VFDs, in the brew house. We had gone from the old style of like a run signal on off and an analog speed signal to a modern Allen Bradley PLC that's communicated to over Ethernet. So the programmable logic controller has access to all hundreds of parameters and feedback, registers in that drive. And why, right? You're just replacing a run signal and a speed signal. You can do that with just the wires that are already there. Sure. Well, the next step then was we had to automate our grain out process in the lauter ton. And we come across the problem of, well, how are we going to detect when the vessel is empty? Well, these modern drives, they estimate the torque current going to the motor. And so we are able to monitor when we're in that step of the grain out process, and we know the rakes are all the way down at the bottom of the vessel. When we see that the estimated torque on the plows get below a certain threshold for a certain amount of time, we absolutely know that the vessel is empty, right? Now, that's not something we imagined early on when we were designing that system. Right. I guess it's just a great example of in this day and age, I think you actually try to be creative and try to throw as much hardware at it as you can. And then you'll figure out ways to use that data later on, right? Yeah. Even if it's just process analytics, sure. How does the torque on that Vorloff pump correlate to the flow rate? And can you use that as some sort of metric to determine pump wear, right? I mean, you can get down in the weeds on this stuff, but the longer you live with the system, the more creative, things you'll find to do with all of this information and data.
Fascinating. All right. Well, then, based off of that, can you give me an example of a problem that you walked into Monday morning, 7:00? Let's pretend, right? The first thing you do in the week, really, it's the problem that you're set up to deal with. You know that it's an issue. You haven't quite gotten into it yet, right? It's not necessarily an emergency, right? You walk into that issue thinking, let me give me a day or so or a couple hours to kind of figure out what the deal is. Another couple hours or a day to figure out how we're going to deal with it. Order the parts, put it in play, no problem. That ended up being phenomenally way more complicated than you assumed it would be. Do you run into those very often? Am I making sense in the first place? And in the second place, Do you run into those? Do you have even an example of those? Do you run into them that much? Problems that should be easy, but are much more complicated than you gave them credit for, I guess.
Yeah, I think a lot of that comes down to, I can think of a number of cases where that certainly plays out in trying to determine the root cause of why did something fail, right?
Right.
So it's that part that I think has more often surprised me than trying to engineer an actual fix.
Okay.
Typically, by the time something's broken, it's pretty obvious. We've got that thing's dynamited. We got to buy a new one.
Makes sense.
Most recently, we actually had one of the blowers on one of our boilers. And it's just a squirrel cage blower. Middle of the day, the thing just disintegrated. It's been in place since I think the build date was 97. So, fine operation. There's no wear parts. It's just two rings of metal with a bunch of little angled slats on it that spins attached to a motor. And middle of the day, the thing dynamites. What caused that? So while we're trying to work through that, we only have 2 boilers in our production facility. While we're trying to work through that and get a replacement made, because they're not an off-the-shelf part anymore, so we're having to scratch build one of these things. The other one blows up, and so this is actually last week. So you're asking this question,
Fresh.
And this is a great example that right now I can't tell you what the root cause is. We're trying to figure out how is it that 2 squirrel cage blowers on 2 separate boilers both dynamited within about a week of each other after 25 years of operation. And
so you mentioned that you mentioned that you have a team. How many people are you working with there?
Yeah, so I've got a site maintenance lead at both of our facilities. So I think you mentioned our size. We're currently 19th largest in the U.S., about 130,000 barrels a year, thereabouts. We hit a peak of about 150,000 barrels in 2015. Working pretty quick to get back to that number with some portfolio changes and some different initiatives internally. It's been a lot of fun. We've got 2 facilities though. We've got our main production brewery in Ohio City, which is like near west side of Cleveland. And then in 2020, we opened up a warehouse and canning facility down in Strongsville, which is about 15 miles away. And we're actually tankering our finished beer from here to there, getting it into bright tanks and canning it. So I've got a site maintenance lead there. We've got at least 1 maintenance individual on all of the operating shifts for packaging lines. And then here in Ohio City, we also have our electrical department. So an electrician and electrical controls technician. I've got 2 engineers that report to me, an EHS specialist, so occupational safety and health, and then a manager of special projects that's focused on some of these larger project initiatives for us.
Excellent. That's quite a team from the context of a 20,000 barrel brewery, which is us, right? So dovetailing into the last question and your example, these blowers go down. It's a mystery. How do you deploy your team to attack the problem?
Great question. We are believers in communication at a very high level, right? So we do shift handover emails between shifts on the maintenance and engineering team. There's a stand-up meeting every morning and really in between all the shifts. And when things like that happen, you'll see a bunch of email chains basically start to pop up. And we will just start sending back and forth pictures, theories, data, anything that we can dig up. So typically you'll see the engineers kind of dive into like some of our process historian data that might be related. You'll see the maintenance guys pulling up maintenance history. Someone else might be pulling up O&M manuals, just operation and maintenance manuals, anything that we can find to help shed some light on, these different theories that are being tossed out. It really is a great team right now. We listen to each other. We share data really well. We communicate excellently. But you'll see these email chains that are just, 2-3 emails a minute, just blasting ideas back and forth. And typically that calms down as we normally kind of go back into the weeds and collect more data and then try to get it to determining a root cause, suggestive actions. How do we correct this? How do we stay ahead of this? Maybe add something to our preventative maintenance program or our daily walkarounds, whatever, to try to stay ahead of it, keep eyes on it. And, so then there's that piece of kind of wrapping up the procedures. Typically go through our one engineer kind of owns our SOP process, standard operating procedure. So any modifications of the SOPs go through him. Safety's involved to make sure we're staying above that line, always first and foremost.
Always.
Like I said, I'm a big safety nut.
Good.
But that's kind of the general process, and that applies to most of the problems that we come across that are worthy of that kind of attention.
So does it become kind of, and again, we're taking this one example, right? Just generally, I suppose we're basing these questions off this boiler fan example. It must be at some point kind of a head and hands type situation, wherever there's a mechanic or a couple mechanics on the ground. They're there, they're looking at the problems there, as you say, taking pictures. They've got their toolkit next to them. They are exploring, right, what could be happening in front of them and communicating that information then back to you. And so they, in this situation, would be the hands communicating then to the head. I have been in that situation a few times. And of course, if the situation is such that the brewery can't function until the problem is fixed, there's a great deal of pressure. I've done it in the head and hands fashion. I'm not saying that's how you do it. That's how I understand it. Where I'm having to communicate to an engineer. Generally, it's a contractor that we're working with. Hey, this is what I'm seeing. This is the problem. I mean, this is the result of the problem. This is what caused me to be here, right? This is what it looks like to me. This is the system as I see it here. These are the pain points that I see could be causing this problem now. Let me work on this for a minute and kind of tear it apart and see, or not tear it apart, but at least dissect it even conceptually in order to get a better idea of what's happening here. Now, of course, as you've said, you have meticulous records on maintenance logs, what the equipment is. I'm sure a lot of that you can do at a desk just by, looking at cut sheets and whatever. So my question is, right, coming from a more primitive process, which we engage in here, admittedly, right? We don't have a chief engineer. We don't have teams. We do have a safety manager, thank God. But largely, we're kind of hands and head right there on the ground trying to figure out the problem. And I am no longer the mechanic working on the machines, thank God, because I'm not the best mechanic that is here for sure. So I know what I do with my mechanics quite often who are here is just kind of say, man, what can I get for you to help you figure this out, right? Let me take as much pressure off of you as possible. Don't worry about the brewery being shut down. Don't worry about any of this kind of stuff. Let's worry about getting to the heart of this problem. You're already motivated. I know you want to fix this. What do you need? Right?
Yeah.
Sort of a primitive way to go about the process. You seem to have a much more evolved way to go about the process. What do you see in the gap between those, or comparing and contrasting?
I mean, I'm hearing basically the same process, to be quite honest. Right?
Okay.
I mean, when we're involved, I mean, I was kind of saying the head and hands. I mean, everyone in our team is in it, right? So that floor disintegrates, and it's maintenance and engineering all standing there asking the same questions.
Okay.
Again, it's just
you are on site dealing with the problem.
Yeah, it's the beauty of having different backgrounds and different expertise looking at the same problem. That again finds that let's creatively lay out all the possible causes here. What are you thinking about? What do you think could have caused this?
Right.
And then communicating back and forth on that's not likely because of X, Y, Z, or that's a great idea. So it's really just about kind of turning up the amplitude on the number of people staring at it. It's not about the background. I don't think it's about maintenance or technician or engineer. It's one team of, if you're mechanically minded, then we've got a problem. Come take a look. Right.
Right. Good.
See what you're seeing that we're not. And
so this is not that different from what it is that we're doing then. I'm putting too much on this, right? There's probably smarter folks involved than me, certainly, but the process is similar, right?
Yeah, I think it's the same process. Yeah, absolutely.
Is it a rat? That's the first question. Did some vermin get in here to cause this?
Yeah. And normally they start pointing at me.
Exactly.
The engineers pick up tools again.
Right.
Smack them out of their hands. Yeah.
Well, but in that kind of high pressure situation, which, even if it doesn't shut the brewery down, there's a sense of urgency in these when something breaks, right? It's not about PM, it's not preventative maintenance, it's broken and it needs to be fixed, right?
Yes.
So there is a sense of urgency. Yes. And that pressure can often, in my experience, that pressure can manifest itself as kind of, emotional sort of outbursts and I mean, managing a team who's dealing with a problem like this is much more complicated. I think the people who haven't done it would give it credit for. What is your experience there?
Oh, absolutely. You
Okay.
talk about how that pressure applies and how it manifests different things in people. It's certainly a challenge. Again, I think I've got a great team now, but it's not to say we all handle that pressure the same way.
Right.
And it's easy to react, to get angry, to, some people put their blinders on and just, get tunnel vision as to the one thing they're thinking about. And again, that's kind of my role, I think, as the manager, certainly, is to try to make sure that we're keeping everything broad, listening to the group, trying to incorporate all the different ideas and hypotheses. And that, again, a few times going through that, I think the entire team is really gotten good to the point where some days I don't know what I do here anymore.
Right. That's good leadership.
It's a good thing. Yeah. Thank you. But yeah, it is interesting to see how people manage that stress. And again, I think that's a little bit of my background, is that startup engineer, or, you're going to all these different customer sites and you've got 2 days to get all this done. You show up day one and find out it's not even mechanically installed correctly, Right. I've been there many times, and so that pressure is not, the pressure I feel here is high, but it's not as high as I've had in other industries, right? Where the dangers were higher, the stress level was higher, and what was on the line was arguably higher as well.
Right.
So yeah, it's always a problem when the brewery shuts down. But again, it can always be worse. So,
really what I'm trying to do here, John, is to make people understand that there is some heroism involved in engineering, right?
I think you have to be a little bit crazy is really what that is. Yeah, I mean, it's the IT manager here and I, we joke about how, the better you do your job, the less people understand, why do we need you? Right? It's everything's working. Why do we need you? And then as soon as everything breaks, it's, well, what have you been doing?
Yeah.
And those are the two extremes, and there's nothing in the middle.
Yeah. But why aren't you doing enough? And what are you even doing here? Those are kind of, there's really not much of a gap in between. Right.
No, but it is really just trying to figure out, all these things are manufactured by human hands out of materials from the natural world. You're just trying to make sure that they keep working towards their intended purpose.
Right.
And that's really all this is. And again, the engineering side of it, maybe, how do we increase functionality or add features and, keep the company agile. I think we were talking a little bit about that earlier, just, trying to stay agile for whatever's coming down the pipe next. If you look at our portfolio of products, ever changing, right? That's kind of the market we're in now. Right. And so, and we just got into our own canning line 2 years ago. And so trying to stay ahead of all that, to keep the company agile and relevant in our customers' eyes is a big part of the role.
So at the risk of being redundant to the 2 or 3 people who I probably employ who will be watching all of these podcasts or listening to them, I have been doing this job as a professional brewer for about 20 years. So long that the first time I went down to Great Lakes, you guys were working out of a brewery in the Flats down there in Cleveland. It would have been like 2003, I think, maybe 2004. And in that time, obviously the brewing industry in terms of marketing and production and when I say production, I mean production of given styles and sensitivity to the market and what folks want, has changed a number of times. It's in it's in a state of flux again. It's always kind of been in a state of flux. And so this agility that you're building into the system works around parameters that don't necessarily have to do with that, right? What style of beer is being made, with some limited exceptions, probably doesn't affect too much what it is that you all are having to work on for the brewery. But You and I talked briefly before the podcast about your own relationship to beer, and a statement that you had made to the individual that was hiring you there.
Yeah,
I'd like to know from the perspective. I'd like for you to tell that story first of all, and then to know what from the perspective of an engineer, frankly, who had worked in any number of different industries and kind of landed and stuck in this one, at least for this amount of time. So from an outside perspective, I know that you work with brewers a lot. What is that like for you? I mean, what were the sort of the challenges or benefits or differences between this industry and others that you've experienced since you've been at Great Lakes?
Yeah, that's a great question. Let me start first with the interview story. So, my history with beer, I admitted when I was on the road a lot, I was drinking beer, was introduced to beers that I'm not going to mention as a craft beer employee. It was not. It was macro beer, right? Is what I was drinking.
Drinking to drink.
Yeah. Eventually made the switch over to whiskey. Eventually landing into Scotch. And by the time it got to the interviews at Great Lakes, I had the opportunity to interview with one of our founders, Pat Conway, and a couple of other members from the team, including the IT manager, who was the only other person at the time that really knew, computer stuff, is kind of how they viewed automation engineering. Great guys. And so Pat asked me towards the end of the interview, well, what's your favorite beer? And I immediately said, well, Macallan 12 here. And I wasn't kidding. He thought I was, and he hired me anyway. But they've turned me into quite a hophead. I still do enjoy a good Scotch. I'm a Islay and Highlands type of guy. So
a little
Ardbeg kind of.
A little saltiness you like?
Yeah, East, draw a line. I'm good. Been to Scotland, have done some Scotch tours, and absolutely loved it. Would love to go back. So that's that story. Asking about the brewing industry and what I love about it. So all these other industries I've worked in, as the automation guy, you're always, like I said, last one in. So you're training the operators. There's a lot of operator and maintenance face-to-face time training and teaching them how the new system works. And something that stood out to me very early on in this industry was the amount of passion and the amount of technicality that exists in the brew house, in all aspects of the business. You go out and talk to our bottling line operator. They're a bottling line expert, and they're always looking for more information. They're engaged. They want to work with you to implement new features, learn how some features work that may have come from the factory. Just learn more and do more. And that was so extremely refreshing. Again, that view that internally we're a service organization within this company. So we're here to serve them, to give them features that they want. And I'll tell you, I stay busy just in that part of it, right? Those guys are the feet on the ground. I come in, I know, like third shift brewer, Dave, always telling me, hey, XYZ happened last night. It was at this point in the process. I don't know why. I was seeing this data. It might be related. Could you look into that for me? Great. Let me,
Yes.
That's the type of question that engages me, that just keeps me energized, wanting me to come in the morning and help solve problems to make this better every day.
You want to kiss him, right? Thank you for giving me all the information I need. Thank you.
Yeah, that energy exists, at all levels in this company on the operations side. And it's a drug, man. They're gonna have to pry me out of here with a stick. I just absolutely love the industry. I love the company. Great culture, great people. It's a lot of fun.
Let me ask you this then: what do people not give brewers credit for that they deserve credit for?
So I would say great question. I'll speak about our brewers in general, and this is coming from me, and I think it goes without saying to a lot of brewers, is that the technicality of what they do with every single batch, the things that they have going on between their ears to make sure that batch is what they expect. I think people see it as a very creative process, and it is. In that way, I think there's some relation to engineering, right? There's a creative level to it.
Sure.
And I think the public sees brewers as, oh, you're the creative. And that may be true at some levels. Certainly by the time you get to our level, they are, I mean, we're making Dortmunder the same way we made Dortmunder in 1988. So
right.
There's not a lot of creativity there.
Yeah.
But the technicality that's going on every single batch to make sure it's exactly what is expected. And, trying to listen to how the equipment's performing and analyzing the raw materials and all those things. There's so much on the technical side that's going on with every batch. In all the industries I've worked at, that level at the controls is it's another standout, right? I think a lot of other industries, you end up with people that are operating equipment that are more or less button pushers. And I can't say that I've seen that pretty much anywhere in the brewing industry.
That is that. I mean, it's no secret. That was the answer I was looking for. Thank you for that. I mean, and of course, you're speaking from the context of a brewery whose consumers depend on consistency, whose consumers depend on, right? You're trying to build lifelong drinkers, right? If you love Dortmunder Gold, and by the way, the 5 people listening to this podcast, you should. And if you don't, try it, right?
That Elliot Ness, man, classics.
Yeah. Right? Elliot Ness, Edmund Fitzgerald, the list, and even the Christmas ale. Man, I'm not trying to dog it. I just think it's a bummer that that's the one that a lot of people know and they don't know any other ones, right? It's really good.
It is.
It is. It is the view of the discipline of brewing that I was trained for and brought up in overseas in Germany, where I got my formal and practical education for brewing. The idea now that you have a lot of these smaller breweries that are the sales and marketing term innovating, is neat, but it's a different way to attack the profession, right? And I would say that to someone like myself, or maybe some of the brewers that you work with, or possibly even yourself, it seems like sometimes a little bit of a cop-out, right? Hey, I did this and it ended up being really cool. I'm having a release at my pub on Tuesday, right? As opposed to this really methodical, well-planned, reproducible. There's much more to making a beer like that, right? Where you're thinking until the end of time, essentially. Is this sustainable, right? Is this reproducible? Than there is to saying, well, I got a tequila barrel in and I spontaneously fermented some wort and then put it in that tequila barrel and now it tastes like funkin' tequila and you guys should buy it at $20 a bottle, right?
This is the thing that is tearing right at the two extremes of craft brewing. I agree.
Right.
I mean, even there's some small breweries around where I live down in Akron that, you walk in and they've got a couple of classic styles on and they taste exactly the same every time you go, batch to batch, year after year. And I'm looking at their little 5-barrel brew house going, man, you're making a Doppelbock just like consistent as all get out, right?
Lights up.
Yeah. And I'm there all day, right?
Right.
At the same time, we are like that realization, we are a consumer packaged good industry. So we've got to listen to consumer. If the consumer is always looking for something new and something super hoppy and all these things, well, I mean, what is the goal of a brewer and what's the goal of the businessman, right? And normally they're the same person. And that I think is the big tear, right? Do you try to do both? Do you try to just always produce that next weird thing that's, super exclusive and we only made a half barrel of it? And, that's really tough because I agree with you that now that I've been in this industry, I think I give a lot of credit to the people that can make some of those clean classic styles well and consistently. I want to meet that guy and share a beer with him.
It's hard, right?
It is. Really
it's hard. And you're talking to a German lager brewer who made his fortune making a New England IPA, right?
Right. Which is delicious, by the way.
No, thank you very much. Yeah, I mean, it's cool, right? It's cool. I feel like it's cool. My kids feel like it's cool because they have an opportunity to go to a state college at least now. But, I mean, it's not, and I'm proud of the beer, right? I'm happy to make it. But once we started making that beer, it was one of those styles at the time, maybe 6 years ago, that, folks expected people who are making this kind of beer will walk down a certain path. And that essentially is tiny variations, tiny differences in the hops that you're putting in, but fundamentally the same base beer, right? No real innovation, just a new label and a new name with one or two new hops that really rest on the foundation of a hop suite that you use for all these beers. And for me, that seemed like a cheat, right? We knocked it out. We were the top selling, and are the top selling beer of that style by dollars in the Midwest. I feel like we nailed it, and maybe now it's time to move on, right?
Do something different, right?
Right. And now, how much money did we lose not doing that? It is difficult to say. But I will say that we do produce what I am proud of, which is a very consistent product that has as much stability as any product of its, with which it shares similarities, and is brewed inefficiently on purpose in order to make it the best example of that style that can be produced at that scale, right? Even if it is more expensive than others, right?
Yep.
Now, we get a lot of shit for that, right? Why don't these guys innovate more? Well, we do innovate a lot. What we don't do is try and trick you out of your cash by putting one different hop in here and putting another label on the beer and trying to sell it to you, right?
Right.
That's a really difficult thing to communicate. And I understand that we're talking about marketing now more than we are about anything else, but these are the progressive issues that any brewer deals with. I mean, that I was working in 2010 and there were issues just like this then, right? I was working in 2003 and West Coast IPA occupied this spot at that time, right? Now all those trials and tribulations are forgotten and it's on to the next thing. And that's the nature of the beast, as you say. But with a brewery like Great Lakes, where dependability and consistency is absolutely paramount, right? That is not to say that you all aren't innovating in the way that a salesman or marketing guy would want you to, or in ways that brewers would want to. But it is to say that your bread and butter is inarguably beers that you've made for a decade at least, right? Decades.
Yeah, 20 years. Yeah.
Right. And that's good, right?
It is. Yeah, and it's funny you mentioned about those public calls for innovation, and of course we want to innovate. Like I said, brewers are a creative bunch, right? We've got our homebrew competitions. We've got all kinds of avenues for the creative brewers on the company staff to be creative, try to come up with that next great thing. Right. But it's how you treat your brands, in my opinion. Again, great marketing question, and we've got a marketing department. But how do you treat your brands? Like you said, you don't want to just change one hop and sell it as a new product. I think that's going to dilute your brands over time, right? Because hanging your hat on consistency is huge. And so, you can innovate, but innovate by coming out with different brands. And it is a little bit longer, painful process, I think, to test them and then slowly develop them into the bigger brands, right? It's tough to say, from our standpoint, we want another Christmas ale, which, you've mentioned a couple of times. I mean, we sell almost as much in some years, if not more, Christmas ale than we do Dortmunder. Dortmunder's available year round. Christmas ale is 2 months.
Crazy.
Right? So our seasonality is just, it's wild. So of course we want to, come up with the next Christmas ale. And we think we've got a couple that are on that path, right? Mexican lager with lime is blowing up. It's helping us, kind of even out that seasonality a little bit. It's a great beer for Great Lakes type activities.
Absolutely.
But trying to make sure that you're innovating, and that's like truly innovating into different brands. And then once you develop that brand, it's got to be consistent, right?
Yes.
It's trying to say, it's kind of like the dress for the job you want, right?
Yeah.
You want to get to the point where your brands are known as a consistently good product, but you have to have that like wild innovation system behind the scenes that kind of feeds into that. But those two almost need to be separate things.
100%. I've got a good buddy that works in Dayton, actually, which is not too awful far from where you guys are. And he went to the same university that I did. We were the only two Americans there. He's got about 10 years on me in the industry. Real smart guy, right? His name is John Haggerty. We spoke to him on this podcast before. John was an architect, or that is to say, he had one job in architecture before he became a brewer, but he went to school to be an architect, right? And he's often, when we've had a couple of beers, talked a little bit about the difference between architecture and engineering, right? In the building trades, and how, architecture is great, and an architect should be able to understand what materials they're using and what kind of weight those materials can bear and how they can withstand the elements, be it wind or moisture or freeze thaw cycles or whatever. But ultimately, the engineer is the one who comes in and says, kind of picks it apart and says, okay, well, this is how it actually needs to be in order to live as long as you want this building to live, or do what it is that you want this building to do. And it's been my thought for some time in brewing that there are folks who are willing to do the conceptual work, which in this case we'll call the architecture, and then willing to do the practical work, which in this case we'll call the engineering, in order to give the whatever brand they're developing the longevity that they wish it to have. And the kick in the balls there is sometimes you do all that work and the brand doesn't happen, right? People don't want it. It came out at the wrong time, whatever. And so it's difficult to get to feel like you've not wasted that work, right? But it's important, and it's certainly what breweries like Great Lakes do. And I feel like when you talk about building a system to be agile and adding all the hardware because there's not that much cost differential, and allowing for a system to be flexible enough to expand or contract given the pressures put on that system, I wonder if it's not pretty much the same. You know what I mean?
Yeah, a lot of similarities, right? And again, I mean, a great tie-in to an example of that is how do you size a lauter ton, right? The system that we bought and we're running on right now was purchased in 1997 when we were making Dortmunder Ness and Christmas ale. Right?
Yeah, 11 and a half, 12 Plato beers, whatever they are.
Exactly.
13. Yep.
So where did the market go since then? Right?
20, 25.
So this is right. So you can think of that as, that equipment is all designed for an ideal. You have to be very careful on what you ask for the ideal, right? This is a question when you buy new equipment, such as a lauter ton, you say, well, what is our mix of products right now? I need a system that can make all of these consistently. But if the trend is to go to a higher gravity beer, then I don't want a lauter ton that is designed for my current product mix. I want to take my current product mix and say, I want a lauter ton or a brew house system that's designed in its nature to make something that's 15, 20% heavier, but can also brew this for now, right? So you start to get into those strategic questions of where are things going? And then you have all the beyond beer questions, right? Can I make the kettle and the whirlpool and all that stuff start to function for some sugar brews? Or there's all those, I'll say, larger strategic questions that go into the engineering of those systems to make sure that when you plop that change down on the table and buy the thing, that it's going to serve you for 10 plus years. Because we were talking earlier, the worst thing you can do, buy something and then immediately have to modify it. It's right. Yeah.
Yes.
We've all been there.
Yes, absolutely.
Yeah.
We have. Well, I wonder, I wonder in all of this, what your thoughts are then about, and we can make this kind of the last topic of conversation, but what your thoughts are then about, given your understanding, my understanding of what's happening in the beer market now. How flexible can breweries actually be? We've seen breweries make seltzer, right? That's a thing that breweries can do to varying degrees of efficacy, right? Non-alcohol bearing products, right? Products that incorporate CBD, for example, are really popular now, right? Here in Michigan, where it's legal, products that incorporate THC are becoming more popular. Beverages, that is. Better for you is the euphemism they use for, low calorie or some added health benefit beverages. Yep. I don't think beer is dying. I don't think beer is going anywhere. I think beer begins to occupy a slightly different cultural niche than it did in the past. But taking Great Lakes as an example, or any brewery, right, as an example, as it stands now, that is well equipped enough to make, let's say, a regional amount of beer, 50,000 or more. What are you seeing when you look into your crystal ball? We've been talking a lot about engineers having to look in their crystal balls, right? So what do you see when you're looking into your crystal ball as sort of the next step here? What are you preparing yourself for mentally? What should engineers and folks who are involved in engineering and breweries be preparing themselves for mentally with regard to technological advances that you've seen, read, or heard about, or changes in the market and building in the flexibility that you've been talking about today?
Yeah, man, great question. I think trying to zoom out a little bit and looking at some of the larger industries and what they're trying to do in terms of newer technology, or again, to keep throwing that word out there, how do they stay agile, right? Designing that agility into your system to try to, because I don't know what's coming next, right? Right now, seltzers are the thing, right? 4 years ago, the not your father's root beer type of, hard sodas were your thing. So what are the common ties there, right? What type of equipment do you need to professionally package that kind of equipment? You're talking about pasteurizers, you're talking about some different equipment that you might not need if all you're doing is making beer. And so you can kind of say for now, well, I'm not going to do seltzers for now, right? Or I'm not going to do this one thing that's hot right now. So I don't need that extra equipment. In reality, I think that strategic view, looking long term, and the last two trends, maybe the last 3 or 4, you needed some equipment to really package that professionally, right? So I think it would be somewhat short-sighted to not consider that for whatever new facility you're going to build, right?
Sure.
And I'm a big fan of Andy Tavikram, if you know him, current president of the NBAA. He worked for Great Lakes until 91. He's currently at Market Garden, which is maybe 50 yards from me here in Ohio City. And one of the earliest talks I remember him giving was about how to design a brew house for future automation upgrades, right? Make sure that you spec a valve that you can take a handle off and put an actuator on in the future, and make sure that you leave room in your design to be able to fit that actuator in without any modifications in the future, right? And so trying to take that approach and apply it to, who knows what's coming next, but I want to make sure that I leave myself just enough room to add capabilities as needed in as easy a way as possible, right? Does that mean, again, addition of a pasteurizer later on, which is going to require an additional boiler, which might require a larger gas line size from the get-go, right? So all you got to do is spend a little bit more money on a gas line for now of a larger diameter and leave a little extra room. And then should that need arise, well, now I can just kind of plug those pieces in, right? So trying to view this as, I use the phrase industrial Lego, right? Trying to view this as an industrial Lego set of,
yes,
be able to plug some things in later on.
Yes.
That's always an approach I think that is going to help us answer what is coming next and how do we respond to it.
So a common theme throughout this conversation, and please correct me if I'm wrong, and maybe the point folks can take from it largely, there's much, much more to cover in your job than we could cover in an hour, of course, is flexibility, building flexibility into systems, building agility into the systems, accommodating to the extent that you can without an actual crystal ball, the ability to grow and change the system, even in slight ways, in order to accommodate then whatever comes next, right? Yeah. So here's a practical question. I said that was the last one, but it's not. Here's a practical question.
And can I add on to that for one quick
Please,
second? Since we're talking agility, I mean, I think we haven't really talked about this. We've been talking about the systems, but the culture is important there too, right? Having a culture where you're willing to try things or willing to think that way, or say, the way I've approached this problem might be not ideal. I want to try something new. That culture needs constant attention as well, right? In my opinion, Absolutely. You got to find the right people and kind of keep that mindset going, that they're willing to try things and willing to think that way, to always be forward looking. So
this dovetails perfectly in the next question I'm asking you. Perfect. All right. You've been at Great Lakes for a while, right? You are the person who manages this department, this crucial department for the brewery, right? And so I would assume that while the folks who write the checks ask you questions, they've grown to accept your answers as practical as possible for their consideration, right? That you're not trying to do something for yourself. You really are trying to better the system when you're asking for money, right?
Sometimes to a fault, yes.
Sometimes to a fault, right?
Yeah.
When you started at that company or at Great Lakes or in other companies for whom you've worked or contracted, you've had to, I imagine, pitch why your solution is the solution that is necessary to the folks writing the checks who have no real understanding of what it is that you're asking for, or why they should spend all this money, or do they really have to spend all this money, or are you just being an egghead about this shit, right? How do you deal with that?
That is a tough one, and you are correct. It's like you were looking over my shoulder in the early days, right?
I've been there, brother.
Yeah, I mean, and it's tough. It's interesting you bring that up. So one of my volunteer roles is chair of the engineering subcommittee for the BA. We had a great meet and greet at CBC a couple of weeks ago. And that was one of the things that came up was how, as the technical troops in our breweries, how do we engage management in a way that shows them that I'm not just looking for shiny stainless toys, right? I'm not just trying to spend your money needlessly. I'm trying to say that, preventive maintenance matters, and we need to start calculating OEE and track the numbers. And there's no one answer, right? This is where at times I've joked, I wish I had a sociology degree rather than engineering. And
100%.
certainly as I've moved into management, right? I mean, that you're dealing with the personalities. You got to know your audience. You got to know how do you show them that, again, you are numbers based, that there is proof in this, proof in the pudding, that I can build out that case and show you in the data why this makes sense. And slowly over time, I mean, the battles seem like you're fighting, there's a lot of battles fought early on, but as time goes on and you start to build those successes, I think the battles either get easier or maybe I'm just getting used to it. I don't know. But yeah, it's certainly interesting, and especially as you pointed out, I mean, I am the head engineer in this company, the head technical person. Well, I say that now with Stephen Powell's on board as our COO. He's got an engineering background, very technically minded as well. But that's an interesting role to be that kind of lead technical, because we think differently. We're weird, right?
Yeah.
Some of those stigmas are well earned. That we're matter of fact. We're very logical thinking, and trying to make those cases in a world that everyone around you thinks differently has been probably the biggest challenge for me here at Great Lakes. It's been fun, and I wouldn't trade it for the world. I think I've done a lot of growing here, but really learning to recognize your audience and what matters to them, and how do you sell your idea, to show that this is the path that we should be considering.
Right. And how to justify dealing with the problem which doesn't exist as a way to kind of look, this problem that we're dealing with now absolutely exists and it needs to be fixed. But while we're in there, right? These are the times when I have saved myself a lot of headache by pitching. My style is, of course, aggressive and pretty, listen, man, I'm laying it out for you. Here are the numbers. This is why this matters. And this is why, doing this now is crucial, because if we wait to do this later, these will be the costs incurred, not just in retrofitting the equipment, for example, but in efficiency lost or time lost or labor lost or whatever it is. Right. And it was bridging the gap between avoiding argument and saying, look, when I was much younger, this is the problem. This is what we need to do in order to fix the problem. Please give me money. Thank you very much. And then go fixing the problem. Right. To, this is the problem. But as long as we're fixing this problem, right, this system also has some improvements that can be made, and they can be made simultaneously. It'll be much less expensive and much less burdensome and set us up for future success if we do this now, right? I'm begging you for this money, please, right? And I think that is a skill that, as you said, develops over time, right, with confidence. But it is a skill that is absolutely necessary. And I think that engineers and brewers, frankly, and folks in many different industries who are practical boots on the ground type people don't get credit for, right? When you talk to the C-suite folks, they're thinking, well, you just don't understand how business works and how money flows. And, we just can't do this just to solve your tiny little problem.
Right.
And sometimes it's okay. I'll tell young brewers who are watching, you got to pick your poison a little bit here. But sometimes it's okay to say, right, you need to note that I told you this, right? You need to note that I said this is the time to do this. I'm comfortable with us not doing this, but I need for there to be a record that I told you this, so that in the future, when what you said comes to pass, you can reference those notes. And that is one way to build trust and a dependency upon yourself from the C-suite folks who don't and won't ever understand the nature of your job and what it is that you do. Right?
Yeah, no doubt. And I think, again, knowing that audience, right, because I told you so almost universally is not a good approach to make
it absolutely is not. And that's not what I'm
tough.
saying.
Yeah.
That's not what I'm saying at all, although I know it does sound like it. It is more the idea of, okay, now we've experienced this problem. Now this is the cost of fixing it, right? I need you to know, right? And I guess this is, I told you so a little bit, but it works for me. Maybe it wouldn't work for everybody, right? I need you to know that this is why I was saying that then. And I know this is after the dust settles and after everything is working well and you're sitting over a beer and, talking about the great times. But to bring it back up and say, listen, man, right? This is why I needed this to happen at that time. It's fine now. Everything worked out. We spent more money than we needed to, and that probably could have been spent in another place better. So I'm not saying that you need to listen to what I say every time. I'm just saying, give me a seat at the table. And again, I'm not talking to you, John, and I'm not talking to myself. I'm talking to young guys who are out there trying to fix problems at their jobs, right?
Yeah.
As you said, find a way, find a pitch, find the way that works for you and the people around you to get it done.
Yeah, and in my opinion, always be open and honest, right? Like you said, sometimes you spend the money and it was the bad spend. And be open about that. Say, we spent this money, here was my approach. But realize that it's not the fix that you're bringing to the table, it's the approach, right? It's the logical approach to try to make things better every time you touch something and keep the equipment operating so that the world around you can continue to brew top-notch beer, right? That's what it's all that we want, all of us, I think. So, again, it's the approach, not necessarily the fix. And I've had egg on my face a few times. You spend some money and you think, oh, this is the right fix. The moment you turn it on, nope, that's absolutely not what I was expecting.
Shit.
Okay, well, we learned something, and try to make the best of it. We'll use those parts over here, somewhere else. Find a path that makes sense. But don't be afraid to admit that you're wrong. And hopefully, the environment that you're working in is such that it understands that, right? Because I've worked not here, but I've worked at other companies where that was not, if you're wrong, you're bad. You're just
100%.
Yeah.
100%. Well, John, I couldn't think of a better note to end it on. And I hope that, young folks who may be watching this in the future, rewind the last 20 or 30 seconds of what you just said. I think it's absolutely crucial and a huge source of advice in a very short amount of time, and so well said for young folks coming up in terms of how they should view the work that they do, whether they're brewers or not. I thank you so much for spending the time with me today. And I get down to Ohio, every couple of years or whatever. Maybe I can look you up and have a glass of whiskey with you.
Anytime, man. You're always welcome here, and I'll look you up when I'm up there next.
All right, that sounds great. Hey, John, thanks again. John Blystone from Great Lakes Brewing Company. Fantastic engineer, fantastic conversation. Thank you again for being here.
Thanks, Travis.
All right, we'll see you later.
Bye.